Hi, welcome to the Euclidean Geometry 101 course. This is part 4 of the series and the last part in a chapter about angles. In this and previous chapters we talked about perpendicularity. Perpendicularity is the way to create right angles, and arguably the right angle is the most important angle in our daily life. And therefore the ability to create perpendiculars is also very important in construction, art, and many other disciplines. In construction especially, this is a crucial technique. Otherwise, buildings would tumble over under the influence of gravity. Since ancient times, the instrument for creating perpendiculars in the vertical plane is the plumb bob. Though not so obvious anymore in English, the word perpendicular originates from the Latin word for plumb line, which is the line you make when using a plumb bob. This lesson and the angle chapter will end with an important proposition stating that we can always create a perpendicular on a line and that there is only one. In the previous parts we defined opposite angles. A proposition about this type of angle can be made. This will be proposition 3, and it says that opposite angles are equal. The proof of this is quite straightforward. Consider the figure. Angle AOC and DOB are equal because they have the same supplement, namely angle AOD, which proves the direct proposition. The converse can be stated as: when two equal angles have the same vertex and have two legs that are in line with each other, and if the two other legs are laying on both sides of the line formed by the first legs, then the two other legs are also in line with each other. We have angle AOC and DOB, which are two equal angles. OB is in line with AO. OC and OD lay on both sides of AB. We need to prove that COD is a straight line. Indeed, because the points A, O and B are collinear, we have that the sum of angle AOD and DOB equals two right angles, and this is according to proposition 2, namely the direct part. But angle DOB is equal to angle AOC, consequently we can write the equality as angle AOD plus angle AOC equals two right angles. In other words, COD are collinear and is a straight line. This is again according to proposition 2, but now according to the converse part of it. We now finish this lesson with a proposition about perpendiculars. Proposition 4 states that from a point outside of a straight line, one can drop a perpendicular on that straight line, but no more than one. Looking at the figure, we need to prove two things. First, starting from A, which is a point outside of the straight line BC, we can drop a perpendicular on BC. Secondly, we must prove that you can only drop one perpendicular on BC starting from A. Okay, let's draw a straight line through A that intersects BC in E and makes with BC the angle M. Let's now draw a straight line through E on the other side of BC, that is, not the side containing A. This line creates with BC an angle N. We make the angle N equal to M. Now, measure on that new straight line a distance E A prime equal to AA. Now draw the segment AA prime. It cuts BC in D and makes with BC the angles P and Q. Let's now reflect the figure AED around ED until the figure coincides with A prime ED. The figure will coincide because 1. E and D are fixed points. 2. EA lines up with EA prime because angle M is equal to angle N. And 3. A coincides with A prime because EA prime equals EA. Therefore, angle P must be equal to angle Q. And that means that BC is perpendicular on AA prime by definition. And so, AA prime is perpendicular on BC because of symmetry. We still need to prove that this perpendicular is unique. Suppose that AE was also a perpendicular on BC, then that would mean that angle M and angle N were right angles. And so angle M and angle N would be each other's supplement. And the converse of proposition 2 tells us that angles that are each other's supplement have outer legs that are in line with each other. So for angle M and angle N, that would mean that EA and EA prime form a straight line. But we already have a straight line. It goes through A and A prime. And thanks to the first postulate, we know that if two straight lines have two common points, they are one and the same. In other words, the straight line AEA prime and the straight line ADA prime must be the same straight line. In conclusion, the perpendicular is unique. End of the lesson for this time. Next time we will tackle the concept of congruency. If you like this series, consider subscribing to my channel.